Okay, we're going to try something interesting this time. You're going to have to bear with me as this is still kind of new to me, but it is very cool. Some people have talked about wanting to rotate their images, and it's pretty simple to do rotation, but even more fun is when you do it with movement and you add the ability to move by thrusting, think of a spaceship in asteroids. Move in the direction that you're pointing instead of just the 4 cardinal directions. So let's take a look at what we can do in our code. Of course, we like to think through the issues first. If we're going to be able to rotate, it means we're going to have an angle. We also have to know the kind of the speed of rotation. We'll call that, rotation. So we have an angle and we have the rotation. And then we have the ability to move. So we want to know if the player has hit the thrust button. And thrust will then be in the direction relative to where they're facing. So we'll add some variables. We'll have our player angle. We're going to start our angle at 0. We can have our player rotation. We'll call it rot, right? That sounds good. We start our rotation at 0. And we're going to have whether or not the player is currently thrusting, which we will start at false. He is not currently doing that. Now, down here in our image, I already actually put it in here, but let me just quick take it out. Our drawing, when we draw an image, there's one additional thing we can do after we say all this thing about how to draw the image on the screen. We can actually put in one more thing down here, which is the angle at which to draw the image at, so we can rotate it. So what we're going to do is we're going to say, okay, we'll go ahead and draw the image at the player angle. This is a measurement in radians, not in degrees, which means, boy, how many radians are there in a circle? I'm really rusty on my radians, but here's the funny thing. When I first go to draw this and I say play, look, it's not rotated. It's just how we wanted it to be. But something's going to come up later where it turns out we actually want them facing to the right to begin, otherwise our thrust gets off. So we are going to actually say, take our angle, which is at 0 right now, and we're going to add about 1.5 radians to that, so that when we draw it, it's now rotated it and we're facing in that direction. To be precise, we might want it to go down a little. You can see it's not perfectly straight, but it's close. And my movement is still working, which means I can move it around on the screen, but I can't rotate, so I can only move in this direction now. So let's see what we can do about that. First thing is our keys. Right now we can move in all our directions, and we don't actually want to do that. So we're going to want to comment out our current movement ability. Now, there's, I think, a special key to do that in Code Sculptor. I'm just going to go ahead and do it manually because I don't remember how to do it. That's what this docs button is for, but oh well. So I think I'm going to set this up so that I can be pressing the arrow keys. Keep it separate from my other movement. So I could hit the left button. And what are we going to do if we press left? Well, what we want to do is we want to rotate or change our angle. So we're going to say if I press the left button, then my player's rotation is going to equal +1 or 0.1. negative 0.1, so we can go counterclockwise, right? Again, subtracting in radians means counterclockwise. Less angle. If I want to go clockwise, player rotation is going to be positive 1. Oops, that should have been an LF. And finally, if I press the up key, I want to thrust. So I'm going to have some player thrust is going to equal true, and we'll figure out what to do with that later. These are some new variables, so in my global right here, I have to say, okay, I'm changing my player rotation, I'm changing my player thrust. I'm going to copy this part to my key up first. Then I'm going to add this part to my key up second. Key up and key down always want to mirror each other. So if I'm not pressing left, I want my rotation to be 0. If I'm not pressing right, I want my rotation to be 0. And if I'm not pressing the up key anymore, I want my rotation to, my thrusting to be false. Now, up here in move player, we are not going to just move our player's location, we are also going to move our player's angle. And this is pretty cool. All we have to do right now is say that the player's angle is going to be plus equal, add to the angle, the player's rotation. We're going to keep these. Right now there is no way to change speed because we've taken all the speeds out, but we'll keep them in there for a second for some magic that's going to happen. But we play this and I turn this way and I can turn this way because my angle is changing. I can't move, but I can rotate. That's pretty cool, right? It's pretty smooth. Sometimes you get some jaggeds, but it's pretty good. All right, now comes mathematical magicianship. What we want to do is we want to add the ability to thrust, and when we thrust, we will go in the direction that we're currently facing. So if I was to press up here, I should go to the right. But if I was to rotate this way and I would thrust, I should go up the screen. How in the world are we going to do that? Well, what we're going to do is we're going to build a function that figures out the vector. This is physics, but figures out the direction we're facing. This is a true helper function. Helper function for angles, angle calculations. I'm probably going to have to cheat and look at somebody's for this. First of all, here's another thing I added. We are going to have to use some math. And we are going to import that. We are going to use sine and cosine as a matter of fact. We don't even need to understand this, we just need to type it in, right? So we are going to say, let's call this angle calc. Now a lot of these functions we've been saying whatever, we don't put anything in here. This time we say, hey, an angle's gonna come into us and we're going to have to calculate something about that angle. And all we really have to do So we're going to return immediately two values because we need to figure out the two different pieces of that angle. We need to figure out the x vector, and we need to figure out the y vector. So we're going to return the cosine of that angle in position 1 in the list. X is always position 0, right? Position 0. And we're going to return the sine as the y vector. So, what we do down here is we say, in the move player, we say if player thrust. So if the player has pressed the thrust button, this will be true, and it will run an if statement. Remember, we don't need to say this because just if player thrust is the same as if player thrust is true. So if the player thrust is true, then our player speed, this is where the speed comes back in. What's our speed equal? Well, our speed equals the angle calculation of our player's angle, but this is the x value, so we need the x vector. This is the x vector right here. So the angle calculation, the first value that sends us back. And then we don't need just that value, but we need the ability to speed up. So we're going to multiply that by a tiny little bit so that the more we thrust, the faster we go. We got to overcome inertia, right? And the second one is just as easy once you understand what's going on, or at least just agree to follow along without full understanding. So, we're changing our speed based on the vector. We're changing our location based on the speed. I didn't double check this works, so let's see what happens. No errors, that's good. If I press the up button, I should thrust in the direction I'm facing. Oh yeah, it's going. It's going. I'm not overcoming much inertia here though, am I? Notice I'm still going in that direction even though I changed, but now I thrust in this direction and I go this way. I thrust in this direction and I go that way. Alright, I think my point 1 was a little bit wimpy. I think it was supposed to be 1.1. That'll get us going with some juice. Look at that. Turn around. Go this way. Turn around, go this way. Now, we're in outer space now. And once we start drifting in a direction, we keep on drifting in that direction unless we hit some inertia going the other direction, right? There's a few other pieces we could add to this to, say, add a little friction so that we slow down eventually. One of the fun things that you can do is add a different graphic, so if you are thrusting, you get a little graphic with fire underneath your belly so you can tell that you've just put some power into it. Right? So you'd want a graphic that can change with the little flames coming out of those boosters there. It'd be interesting if I could get it to not move at all, but I think now I'm stuck in a movement. If you bear with me, I'm going to peek at something and find out how to stop that. If you're happy, I'll see you later. Enjoy your rotation. If you want a little bit more, here's where I'm getting this information from, a project I did a while ago. Right here is where it added some inertia to the matter. So it just took it down by a tiny little bit. So we have to multiply 1 minus 0.01. That sounds about like 0.99 to me, but that's okay. So not in the if thrust, but just all the time, no matter what. The player's speed of his x vector is going to be multiplied onto itself 1 minus 0.01. And the player's speed of the y vector is going to be multiplied onto itself 1 minus 0.01. I think we do it that way because then if we change our mind, we want to make more or less inertia, we have the ability to do that. So I'm moving, I let go, oh, I come to a slow stop. I press up, and as I let go, I come to a slow stop. That's pretty awesome. Now, this right here, this is the speed at which I'm going to get myself moving. So the higher this number goes, the better my thrusters work. Right? So I change that number, and now I can start getting faster. Yeah, that's still not too fast though, is it? See how I slow down to a stop? I'm also overcoming the direction I was moving really fast. So I still feel like there's some physics that I could work on here. The exciting thing about this inertia is I think we can use that even if we're just moving left, right, up, and down, and it will skid us to stops instead of having us constantly just immediately stop. That could help us in all sorts of interesting applications like jumping ability. If you play Mario, when he gets to the end of something, if you stop pressing it, he still moves a tiny little bit when you're not pressing it. And then he comes skidding to a halt. So we've got ourselves some bona fide physics. Enjoy. This was fun. I think we can make some great things from this, so I'll let you think about it. I'll see you next time.